All right, so today we're going to go over component 2, which is arc length. So before we can really get into arc length, we need to be talking about the degree of an arc. So if you remember, a central angle of a circle is an angle with a vertex at the center of the circle, right? So this angle right here, the center is B, so this angle is called a central angle. Okay, the sum of all of our central angles is always 360 degrees. So a circle adds up to 360 degrees. So some of our central angles here could be angle PAQ. Another central angle could be RAQ. Another angle could be SAR. We could have another one, SAP. Now this could keep going. Technically, we could even do SA to Q and skip over P, and that'd be this big angle where these two are together. So that would be angle SAP, and this could go on. Oops, I said that. I meant to put a Q here. And this could go on. So there's lots of central angles. Okay, now an arc is a portion of the circle. So this is a central angle. Connecting P to Q is called an arc. Okay, so there's a couple different types of arcs. There are minor arcs. So a minor arc is the shortest arc connecting 2 points on a circle whose measure is less than 180. So a minor arc is less than 180. So for example, CAE is less than half of the circle. 180 is half of the circle, so less than half. Okay, a major arc is greater than 180, so that would be greater than half the circle. So something that would be bigger than half of the circle would maybe be from D all the way to B. Okay, so that would be a major arc from D all the way to B. Now, the way we say if we want it to be a major arc, technically D to B would be the smallest one. So we have to give it another letter so that we know we're going the big way. So we're not going to call this DB, we're going to call it maybe DC to B. Now I did this wrong. It shouldn't be the angle. It would be arc C to E would be a minor arc. This should be C to E. Oh, I keep writing it wrong. Now a semicircle is exactly 180, so it'd be exactly half of the arc. So that would be maybe D to E would be half of the circle. D all the way to E would be half of the circle. Okay, so in this next example, they want us to give examples of a major arc, a minor arc, and a semicircle. So a major arc is more than 180, so maybe G all the way to L. But since it's a big arc, we've got to stop halfway maybe. So G to J to L. A minor arc would be small, so that would maybe be just G to L, the short way, versus G to L, the long way. And then a semicircle would be G to J, halfway. Okay, I'm going to let you guys do this one on your own. Okay, so an arc length. So if I want to find the length of an arc, okay, so one place to the other, we use the equation 2 pi r theta over 360. Now you don't have to memorize this formula, we will give it to you on your quiz. Okay, now R represents the arc or the radius. Theta in this case would be the number of degrees. So if it makes more sense, we could call it x degrees over 360. So for example, if I want to find the length of z to y, so the length of z to y would be this guy right here. So think about it as what we're doing is we're measuring the length of this crust of this pizza. I want to know, is that 3 inches? Is that 7 inches? Or I want to know what that length of that crust of the pizza is. So we're going to use our formula. So arc length is going to be equal to 2 times pi times r, which in this case is 4. 4 is the r, times x degrees. Now make sure the 75 is pointing to what we want to find. It is. So times 75 all over 360. Now we're going to plug that into our calculators. So I would suggest using your fraction button. So the fraction button is alpha, the green button, and then equals, or excuse me. So right here, alpha, and then y equals. It gives you the fraction, and then we can type in 2 times pi times 4 times 75 all over 360. We're going to round to the nearest hundredth, so that's 5.24. Okay, so let's do another one. Okay, so in example B, we want to find z to y again. So z to y would be this guy right here, the arc of that length. So our formula is 2 pi times r times the degrees all over 360. So this 10 is actually the diameter, which means the radius would be 5. Now make sure this 130 is pointing to our arc. It is, so I'm allowed to use the 130. Plug it into our calculator. So alpha y equals makes the fraction 2 pi times 5 times 130 all over 360. Gives us 11.34. So the length from here to here is 11.34 centimeters. Okay, why don't you guys try C? I'm gonna jump down to example 8. So on example 8 here, we want to find the length of A to B. So A to B would be this guy right here. Okay, so we've got 2 pi r times the degree all over 360. So once again, this 10 is actually the diameter, which means our radius would be 5. Now if we look, this 130, is it pointing to what we want to find? It's not, right? This 130 is not pointing to the purple highlight that I have here. So I can't use 130. So we have to understand that this line right here is cutting the circle in half, which means that it's 180 degrees, right? Because I'm cutting the circle in half, it's making a line. So if this is 130, then I have to subtract that from 180 degrees to get that missing angle. So this angle is actually 50, and now that number is pointing to what we want to find. So we're not going to use 130, we're actually going to use 50. And now I'm going to go to my calculator and plug that in. So 2 pi times 5 times 50 all over 360 gives us an answer of 4.36. Okay, I would like you guys to try these problems on your own and check your answer on the answer key. Now on the next page, it's actually asking us to go the opposite way. So it's saying find the measure of the find the length of the radius. So I'm actually going to jump down to number 10 first. So on number 10, I don't know the radius. So our radius is what I'm trying to find. That's x. It's telling me this answer here is 2.1. So I'm not trying to find this. I know this answer is 2.1. We got to make sure our angle is pointing at what we're finding. It is, so that's a good thing. So in this problem, instead of me saying our arc is equal to 2 pi r times x degrees over 360, and me plugging in r and x, this time 2.1 is our arc length. So 2.1 has to replace the arc length. Then we have 2 pi. Now r I don't know, so I'm going to make that an x. And the degrees is 75. Now I have to use my algebra to get x by itself. So how are we going to do that? Well, our first step is the opposite of dividing by 360 would be multiplying by 360. Opposite of dividing would be multiplying. So I'm going to multiply by 360. So we get 2.1 times 360, and that gives us 756 equals 2 pi times x times 75. Okay, well, 2 times 75 is 150. So we get 756 equals 150 pi x. So if I want to get x by itself, the opposite of multiplying is dividing. So I'm going to divide by 150 in pi. Once I divide that in my calculator, x is all by itself, and that's my final answer. So just like we've been doing, we're going to use our fraction button. So we're going to press alpha y equals to get our fraction. And we're going to have 756 divided by 150 pi, which gives us 1.60. Okay, so the reason I skipped number 3, let's go back and do number 3, is that it's telling me that this arc here is 3.3. But just like in those other problems, we have to ask ourselves, is this 104 pointing to the right thing? And it's not, right? 104 is not pointing to the right thing, so I can't use 104. I need to know what this angle is. Well, a whole circle is 360 degrees. So if I do 360 minus 104, that will give us the angle that we want. That gives us 256. So this angle is 256. Now that's pointing at the right thing. So our arc is 3.3. 2 times pi times r, I don't know, so let's make it x. The angle is 256 all over 360. Okay, so step 1. Can't have that 360 there. So the opposite of dividing by 360 is multiplying by 360. So 3.3 times 360 in our calculators gives us 1,188. 2 times 256 gives us 512 pi x. Final step, divide by 512 pi. Use your fraction button, 1188 divided by 512 pi. We get x equals 0.739.